Now coming to the metallurgy part, that is in the metallurgy part we are having the what you can say the extraction of the metals. So before going to the extraction of a particular metal, that is aluminium, we need to know something about the terms which are involved in it. Achha. So coming to the terms, that is when you are extracting a metal, what are the first steps we should do? What are the steps you should take for the extraction of a metal? See, 4 steps are there. There are 4 steps for extraction of any metals. What is that? Number 1, concentration of the ore. Second one, to convert the concentrated ore into its oxide. Third one, reduction or smelting, we can say that. The fourth one is purification. These are the 4 steps. Again I repeat, the first step is your concentration of the ore. Alright, I'll tell you what do you mean by the concentration of the ore. Second is to convert the concentrated ore into its oxide. The third is the reduction of the ore or the smelting. Alright, the reduction of its oxide to its metal, we can say that, or smelting, we can say. The last is your purification of that particular metal. After the extraction of the metal, we have to purify that metal. So these are the 4 steps which are involved in general for extracting any particular metal. Now I will come to tell you what is meant by the concentration of the ore, we can say that. So what I said, in case of concentrated ore, we convert the impure ore to the pure ore. Impure to the pure ore. Now coming to in this what you can say aspect, we will see what is the meaning of the term metallurgy. Alright, we are studying the chapter on metallurgy. What is the meaning of the term in this particular aspect? Because we have come to the extraction of metals now. Previously we were talking in general between metals, non-metals, alkali metals, metals and all these things. So comparative term we have done it. Now coming to this particular aspect, what is metallurgy? The large scale process involved in the extraction of pure metals from the respective ores is called metallurgy. The large scale process involved in the extraction of pure metals from its ore is called metallurgy. Because I said, you know, what is concentration? I said concentration is nothing but to convert the impure ore to pure ore. So we are involved the what you can say the process of metallurgy. Concentration comes under the process of metallurgy, we can say that. So what is metallurgy? It's nothing but it's a process. It's a what you can say phenomena which involves the extraction, again I repeat, of the pure metals from its ore, from its respective ore is called metallurgy. Now what is an ore then? What is an ore? Alright. Ore means the naturally occurring minerals from which metals can be profitably and conveniently extracted is called as an ore. Alright. What I said, ore is nothing but a naturally occurring mineral from which metals can be extracted profitably and conveniently is nothing but known as an ore, we can say that. That is called as ore. So we are having different types of ores we are having. The ore can be in form of carbonates, it can be in form of halides, it can be in form of sulfates, it can be in form of sulfides, we can say that. Alright, the ore can be in the form of carbonates, in the form of halides, in the form of sulfates, in the form of sulfides. Like also it can be in the form of oxide also. Definitely in the form of oxide also we can get the ore, we can say that. Alright, so we are having, that is a marble, that is calcium carbonate, we can say calamine, that is zinc carbonate, fluorspar, that is CaF2, fluorspar, 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 cryolite, 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 Na3AlF6. Similarly, we are having galena, PbS. We are having zinc blend, ZnS. We are having anglesite, PbSO4, we can say that. We are having Epsom salt, MgSO4.7H2. We are having barite, BaRyte, barite, BaSO4. We are having bauxite, Al2O3.2H2O. We are having hematite, Fe2O3, we can say that. We are having zincite, ZnO. In this way, many more ores are there. Many more ores are being there. Some of the name of the oxide ores, the sulfide ores, the sulfate ores, the carbonate ores. Alright, the halide ores, I have just told you some of the names. You are having definitely a chart in your book. You must go through it. The short question comes upon here. You will be getting the short questions upon it. Got it? Mind it. So you need to remember the name as well as the formula. Alright, like I said, that is zincite. Zincite means what? Zinc oxide. Suppose when I say fluorspar, what is that? CaF2, that is said to be as. Clear? So you need to remember in this particular way. Now, I said you what is an ore. Now, next is mineral. Then coming to the mineral, another definition we can have it here is the compounds of various metals found in nature associated with earthly impurities are called minerals. Alright, what are minerals? The compounds of various metals found in nature associated with earthly impurities, they are called as minerals. Earthly impurities means like rags, twigs, hair, clothes, got it, papers, we can say that. This is known as the earthly impurities, we can say that, along with clay, mud and all those things. Next is, after that, matrix or gang, G-N-G-U-E, spell it correctly, G-A-N-G-U-E, it is known as gang. Got it? Matrix or gang, the rocky impurities including silicon dioxide, that is silica rather I should say, SiO2, mud etc. associated with the ore is called matrix. The rocky impurities containing, that is silicon dioxide, that is otherwise known as silica, along with mud, along with what I can say, other impurities which are being there. Other impurities means definitely, suppose if I am extracting aluminium, so rest of the things are the impurities. Alright, rest of the oxides, sulfates, carbonates of other metals, they are the impurities. Alright, so they are known as matrix or known as gang particles, we can say that. Next is flux, F-L-U-X, flux. Now, the substance added to the ore to get rid of the matrix, alright, resulting in the formation of a fusible compound known as slag. Alright, the compound which is added, the substance which is added, the compound which is added to the ore, alright, which is added to the ore, which is added to the ore to get rid of the matrix. Alright, matrix means the gang particles, I said it, the unwanted particles. Alright, resulting in the formation of a fusible compound. When this substance, the flux we are adding to the ore, alright, to remove this, what you can say, gang particles or the impurities of the matrix, it forms a fusible compound. This is otherwise known as slag. You understand the meaning of the word fusible compound means? Which results in the formation of an addition compound. Many more compounds come closer and it forms an addition compound with it. That is called fusible compound. Next is the smelting. I use a word here, smelting, when I was saying the different processes. That is, I said you, the process which are involved, the 4 steps which are involved for the extraction of any metal is nothing but is your concentration of the ore. Then we are having the concentrated ore to its oxide. The next step is, then I said, reduction or smelting, and the last one is refining. Alright, that is purification of the metal, we can say that. Now, in that smelting, so what do you mean by smelting? Smelting is, it's a process of reduction of the roasted ore, got it, to the metal in a molten state. Got it? After removal of the rocky impurities associated with the ore, that is the gangue particles, the rocky impurities means the gangue particles, is known as smelting. And generally smelting is carried out by using carbon as a reducing agent. By using coke, carbon means coke, C as a reducing agent, we can say that. Clear? So what I said, smelting, the process of reduction of the roasted ore, because after roasting we go for smelting or reduction. Alright, after roasting, I said it, again I repeat, first we go for concentration, where the impure ore is converting to pure ore. Then we convert the concentrated ore into its oxide. Alright, that is, how do we convert? We convert either by roasting or calcination. I'll tell you in details. Now the roasted ore is heated with carbon, with coke. Not in all the cases. Not in all the cases. In certain metals only, like in case of zinc. Alright, like in case of lead, we can say that. The roasted ore is heated with, that is what you can say, coke or carbon, which acts as a reducing agent. Which acts as a reducing agent. Here coke or carbon, it acts as a reducing agent. Alright. So this particular process is known as smelting. Again I repeat, the process of reduction of the roasted oxide ore to the metal in the molten state, including removal of the rocky impurities, we can say that, associated with the ore, alright, is otherwise known as smelting, we can say that. Alright, that is called as smelting. Fine. So in this way, these are the terms which are involved in it. Now coming again back to the concentration, the first step. Concentration, we are doing it by what you can say 4 methods. We are doing it. One is your magnetic separation. Another is your flotation method. The third is your gravity separation or hydrolytic method, we can say that. And the next is your leaching, which is a chemical method. Leaching, 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 which is known as a chemical method, we can say that. Clear? I will come to it one by one. But before that, it's a little bit more I have to say you about this particular process. So that is what we do is that is concentrated or concentration. I said you we go for this particular method. Now for which particular metal, which method is being useful? Now if you see the metal activity series. If you see the metal activity series starting from potassium to aluminium, let me write the metal activity series once again. That is popular scientist can make a zoo in the low humid country more. This is copper satisfactory. Then it is PT. AU. Alright, so what I was talking to you, that is this part I was talking to you, that up from potassium to aluminium, you can see it here. Potassium to aluminium, that these metals, they are highly reactive, we can say that. They are highly reactive, they have got strong affinity for oxygen. These metals, they are highly electropositive also, because it forms K plus, Na plus, Ca2 plus, Mg2 plus, Al3 plus, highly electropositive elements, we can say that. They have strong affinity for oxygen. Their metallic oxides cannot be reduced. Listen carefully this sentence. Their metallic oxide cannot be reduced by ordinary reducing agent. Got it? Means after converting the concentrated ore into its oxide, we go for reduction. So here we cannot get the metal by the process of reduction. We cannot get potassium, sodium, calcium, magnesium, aluminium by the process of reduction. We cannot get it. Why? Because I said you, their oxides are highly stable. These elements have got strong affinity for oxygen. Suppose, let us say, you have reduced also the metal by using carbon as a reducing agent. For example, let us say we got Na2O. Let us say Na2O. Na2O plus carbon will be getting Na plus carbon monoxide. Again, sodium will combine with oxygen to form again Na2O. Again, alright. So that is the thing I am saying you, that these elements have got a very strong affinity for oxygen. So even if you reduce it by ordinary reducing agent is your carbon, carbon monoxide, hydrogen. Alright. So they are called as ordinary reducing agent. If we reduce it by ordinary reducing agent also. Alright. At the same time, again it will react with oxygen to form again the respective oxides. Because again and again I am saying you, it is having strong affinity for oxygen. So these elements, these metals cannot be reduced by ordinary reducing agent. Then what we will do then? We are going to reduce these metals, we are going to extract these metals by the process of electrolysis. You have studied in electrolysis chapter, I have said you electrometallurgy. You will take the salt of these particular metals like potassium chloride, sodium chloride, calcium fluoride. You will take the salt of these metals and you will go for electrolysis, where at the cathode the metals will be collected. Cathode is negatively charged electrode and these metals are always positively charged. I said you electropositive. So they will be collected at the cathode. Understood now? Because these elements have got strong affinity for oxygen, so they cannot be reduced by ordinary reducing agent. So they have to be extracted by the process of electrolysis. Fine. Now from that is zinc to copper. This up to zinc to copper. So they are being reduced by reducing agent like carbon, carbon monoxide and hydrogen. These particular metals, they are extracted by reducing its oxide. That is, we go for smelting also, as I said. Alright, by reducing agent like coke, carbon monoxide, hydrogen, we take it. Fine. Now, mercury, silver, platinum, gold. Now, platinum, gold is already available in the free state in the nature, we can say that, because they are the noble metals. Alright, so these metals, mercury and silver, basically we can say that. So they can be extracted by heating its oxide. Alright, for example, if you take mercuric oxide, alright, if you heat it, its oxide, it will give you metals. Mercury oxide, you have done it in the lab also. You have taken the mercury oxide and you have heated it. You got the oxygen gas and mercury remains behind in the test tube. We can say that. Clear? The silver, the deposition on the walls of the glass tube. I don't know whether you remember it or not. So in this way, there is mercury oxide on heating will give you oxygen. It's a dry test tube heating. You've done it in the lab in class 9, so to say. You might have done it. So in this way, that is, these metals can be extracted. That is mercury and silver. These metals can be extracted by heating its oxide. If you heat the oxide, like mercury oxide, silver oxide, if you heat it, it will give you respective metals and oxygen gas will be liberated. So you understood that how these metals are extracted. I told you the process. Fine. Now next is for what you can say this reducing agents. Let me say you once again, like reducing agent here, what I use it, let me say you once again, from zinc to copper I use the reducing agent either as coke, or I use carbon monoxide, or I use hydrogen. Alright, and I reduce it, this particular one. Alright, but first it needs to be converted into its oxide. So how to convert it into its oxide? By either calcination or roasting. I'll tell you that is calcination and roasting, so to say. Now next is one more thing, you remember it, the oxides of these particular metals, oxides, not only oxides, hydroxides, carbonates and nitrates, upon heating does not, like oxide is very stable, let me tell you, potassium, sodium, oxide, they are very stable to heat, they do not decompose. Like potassium oxide and heating will not decompose into potassium and oxygen. Sodium oxide and heating will not decompose into sodium oxygen. Alright, similarly, their hydroxides, potassium and sodium, hydroxide are also stable to heat. Like potassium and sodium carbonate, also they are stable to heat. As well as their nitrates are also stable to heat. If at all you are heating the nitrate, it will give you nitrite and oxygen. For example, KNO3 on heating will give you KNO2 plus O2. Alright, it will not give you the respective metal. Potassium nitrate on heating will not give you oxide, potassium oxide, or it will not give you potassium. We can say that. That is what I want to say. So the what you can say here, let me have another grouping here. That is, potassium and sodium is stable to, their oxides are stable to heat. Their oxides are stable to heat. Their hydroxides are stable to heat. Their carbonates are stable to heat. Their nitrates are also stable to heat. Only the nitrates decompose into nitrite and oxygen. You must remember this. Alright, fine. Now coming from calcium to copper, their oxides are stable to heat. Calcium to copper. Their oxides are stable to heat. You may write down all these things. Write it down. Make a note. Alright, make a note. That is, they are their oxides, calcium oxide, then aluminum oxide, zinc oxide, they are stable to heat. They do not decompose on heating. Alright, only I said you know, that is mercury and silver oxide. They decompose on heating into respective metal and oxygen. You will be getting it. Alright, fine. Now, if you take the hydroxides, they decompose, that is hydroxide means from calcium to copper. If you take the hydroxide, now I am talking about this category. That is, their hydroxides decompose to give you respective oxide and water. For example, if you take calcium hydroxide, CaOH whole twice, on heating will give you CaO plus H2O. Of course, you will balance it. Similarly, aluminum oxide, hydroxide and heating will give you aluminum oxide and water. Zinc hydroxide and heating will give you zinc oxide and water. Alright, fine. Now from calcium to copper, if you take the carbonates, alright, the metallic carbonates, like calcium carbonate on heating will give you calcium oxide plus carbon dioxide. We can say that. From calcium to copper, they decompose to give you oxide and carbon dioxide. Any carbonate from calcium to copper will decompose to give you oxide and carbon dioxide. Like I am giving an example for that reason. Calcium carbonate. Suppose if you take magnesium carbonate, it will give you magnesium oxide and carbon dioxide. If you take zinc carbonate, it will give you zinc oxide and carbon dioxide. Fine. Now, if you come to the nitrates, alright, calcium nitrate on heating will give you calcium oxide, nitrogen dioxide and oxygen. From calcium to copper on heating, nitrates, alright, from calcium to copper on heating its nitrates, they decompose to give you oxide, nitrogen dioxide and oxygen. For example, same thing, calcium nitrate, CaNO3 whole twice, on heating will give you CaO plus NO2 plus O2. You will balance it, this one. Later on, you'll balance it. You have to balance it. Don't write an unbalanced equation. It will give you 0. Alright, if you tell me 2CaO plus 4NO2 plus O2. See, it is balanced. It is 2CaO plus 4NO2 plus O2. It is balanced. We can say that. So, in this way, from calcium to copper, if you take its nitrates, you will see it decomposes to give you oxide, nitrogen dioxide, oxygen gas is being liberated. Okay, fine. Now, mercury to silver, if you take, I've already said it, its oxide decomposed to give you metal and oxygen gas is liberated. Now, hydroxides of mercury and silver do not exist. Alright, listen carefully. The hydroxides of mercury, hydroxides of silver do not exist. Alright, they are rarely found in the nature. Rarely, they do not exist at all. Means they are not stable, so to say. Now, mercury to silver, that is two metals, they are carbonates decomposed to give you metal plus carbon dioxide and oxygen. Means if you take that is mercuric carbonate, it will decompose to give you mercury plus carbon dioxide plus oxygen. We can say that. Clear? In this way, there what you can say, if you take, this is mercuric I have taken, not mercurous, mercuric carbonate. Clear? On decomposing it, on heating it gives you the carbonate, on heating it gives you, that is nothing but mercury plus metal plus, mercury plus carbon dioxide plus oxygen. So you will be getting metal plus carbon dioxide plus oxygen. If you take the nitrate here, nitrate, mercuric nitrate if you get, if you take, on heating will give you mercury plus nitrogen dioxide plus oxygen. So, from mercury to silver, their oxides on heating gives you metal and oxygen. Hydroxides are not formed. Carbonate and nitrate on heating will give you metal. If it is a carbonate, then it will give you metal, carbon dioxide and oxygen. If it is a nitrate, it will give you metal plus nitrogen dioxide and oxygen. We can say that. Clear? Now, next is one more thing you need to remember. That is all these, that is mercuric oxide or silver oxide, mercuric hydroxide, silver hydroxide, of course it is not being formed. Got it? And mercury carbonate, silver carbonate, they are all insoluble in water. Insoluble in water. Nitrates are all soluble. They are insoluble in water. You need to remember it. Alright. Even from calcium to copper also, these particular oxides, carbonates, then hydroxides, we can say that they are also insoluble in water. I am not using nitrate. Mind it here. I am not using nitrate. Nitrates are soluble. Alright. Clear. So in this way, but in case of potassium and sodium, the oxide, hydroxides, nitrates, carbonates, all are soluble in water. Remember that. All potassium, sodium and ammonium salts are soluble in water. Again I repeat. All potassium, sodium and ammonium salts are soluble in water. Alright. So this is a general again discussion about metallurgy. We did it. Now we will come to the, what you can say, the process. The first we are going to start the concentration of the ore. Next area.